Hello everyone, for this video we will do the operations that we did in the previous video using the Numpy or the Numpy library. So as you can see here, we have a Jupyter notebook set up here. So if you don't know how to set up a Jupyter notebook yet, so I will put links in Moodle on how to install this setup. So the first thing that we need to do is to import the library. So import the Numpy library as NP. So we run that. Just press Shift Enter. Then so the first operation that we're going to demonstrate is the vector addition. So let's set up some vectors. Matrix addition. So let's set up some matrices here. So np.array. So let's say we want a two-dimensional array. So 1, 2, 3, and then 4, 5, and 6. 5, 6, and then let's make another array B. So you want this to be all ones. So that's easy to assess the addition. Okay, so we now have our A and B. So let's try to print our A and B. Print A, and we'll print our B. So these are our matrices. So we have 2 by 3 matrices. So if you want to add them, you simply have to just do A plus B. So let's say we want to set C, use C as our variable here, and then we use A plus B. You Shift Enter that. Now let's just print C here. Print C. We will get here. So all of the elements have been added with 1. So that is what we discussed in the previous video, right? Just add all the elements together. So now that we've done that, so the next thing that we need to demonstrate is the scalar multiplication. So let's say we want to use this matrix A. Say we want to multiply 2 to this whole matrix. So how do we do that? So let's say let's use the variable B, and let's multiply 2 multiplied by A. Okay, vector A. So let's say we print D. So this is the result. So 2, 4, 6, 8, 10, 12. Okay, that's for scalar multiplication. Now, how about matrix multiplication? So let's try out matrix multiplication. So how are we going to do that? So let's say we multiply. For matrix multiplication, we use np.math. The function here is math_mul, and then just type the matrices that you want to multiply. So as you can see, we have here an error. So why did we have this error? We have this error because we are trying to multiply a 2 by 3 matrix by a 2 by 3. So that is not possible because we have in this particular row for A, we have 3 elements, and then the first column for B only has 2 elements. So that is not allowed in matrix algebra, right? So for this, for multiplication, let's use other matrices. So let's create other matrices. So let's just use square matrices for simplicity. Okay, so we have, let's say I want to create a 3 by 3 matrix with the random values from 1 to 10 or 1 to 9. So I can use this function random.rand and then int. So this creates random from 1 to 9. So this is exclusive, so it does not reach 10. It only reaches 9, so 1 to 9. And then the third argument is size, and then this should be equal to a shape, so 3 by 3. So let's try to print our x. In our x, we have this random matrix here from 1 to 10 elements. Okay, so let's say we want to create another matrix with all values are 2 and it's still 3 by 3. So we can do that by using this this method right here, full np.full. The first argument is the shape of the matrix, so 3 by 3. And then the second argument is the integer that you want that you want to fill the matrix with. So let's say 2. So let's try to print our y. So we have this right here. So don't worry if you're not quite familiar yet with the syntax. I will also put another link, a URL for a YouTube video presenting all of the syntax right here. Okay. So now we can perform matrix multiplication on these two vectors, right? So let's say we want np dot matmul, and then that will be x and y. Press enter, and there you have it. So this is the result. Okay. So the next thing that we need to do is the inverse. Okay. So for the inverse, the function for that is np dot. We use the linear algebra linalg dot inb function. Okay. Inverse. So you just put the any argument here, the matrix that you want to get the inverse of. Okay, so let's try. You want to get the inverse of x. So the inverse, x inverse is equal to np dot linalg dot inverse, and then we put our x here. Okay, so let's try to print. Okay, so this is the inverse of x. Oh, I'm sorry. This is not the inverse of x. This is x. Okay, so this should be... Oh, so this is the x inverse. So that was weird. Okay, so let's test now. So we said in the previous video that if you multiply the array with its inverse, you get the identity matrix. So let's try to see if that is really the case. Let's use the variable result, and then x multiplied by, and then np dot matmul, and then x, and then the multiplied by the x inverse. So let's try to see what happens here. So let's print it. Print, and then result. You see. So as you can see here, there are some slight errors. As you can see here, we have here the diagonal is almost 1, right? And then the other values aside from the diagonal are very close to 0. It's not 0, but very close. So this is the limit of the float, because you cannot write. There is only a limit to how many decimal places a float data type can handle. So that's why we have here some limitations. So what we can do, if you really want to see what we call this, an identity matrix out of this operation, so we can round it first before typecasting it to an integer. So for converting it to an integer, so np round. So this is the function that we need to use. So result, and then after doing that, dot as type, and then you put in. So there you have it. This is our identity matrix. So it does indeed work. Okay. So the last operation from our last video is the transpose. So you can do that by using np.transpose. Okay. We have argument right here. So let's try that. Let's try to transpose our x. So let's print our x here first, so that we can really see the difference. So we have here our x, and let's say we want np transpose, and then our x. So there you have it. So this is our transpose x. Okay, so that's it for the necessary matrix algebra that we need to know in Numpy for this particular lesson. And if you want to learn more of Numpy or Numpy, so I will put a tutorial video, upload it on Moodle as an additional resource, and you can explore that as much as you know. Okay, so thank you for watching this video. I hope you learned something new, and I will see you in the next video.